Hey you guys, this is Mr. Sal. We're just going over 2.1, Substitution and Elimination. This is systems of equations. In this unit specifically, we're looking at systems with two variables. So thanks for watching. Don't forget to like, comment, and subscribe. Alright, so when we look at a system of equations, a system just means that there's more than one equation. Sometimes there's three, sometimes there's four or five. The maximum for this class is 3, though, which we can be grateful for. If there's 2 variables, there should only be 2 equations. If there's 3 variables, there should be 3. And if that were the case, we would call it an ordered triple, which would have all 3 values on it. All right. So a 2-dimensional graph is something we should be very familiar with by now, right? If I had this red line and this purple one, they would intersect at this green dot, and that would be the solution for these two. However, when we start adding a third dimension, that doesn't look great, but we can have a third line as well that kind of goes through that same point. Actually, it's a little bit different than that. We'll look at those when we get to the 3-dimensional stuff. Now that's a lot of writing. It's probably not as complicated, so complicated as this. But, in fact, this is really just for 2 variables, though. 3 variables, we kind of simplify it, but it includes this process as well, okay? So, if we can write the equations in the same form, then usually elimination is good. If not, then substitution may be a more appropriate method. But for now, we're going to be looking at elimination, which is good if we have standard form. Then we'll multiply the equations by non-zero numbers, just making the coefficients the same of whatever variable we want to eliminate, and then we'll actually add those 2 equations together, eliminating the variable that we want to, or we chose to eliminate. And it doesn't matter which one we choose to eliminate, just, get rid of it once you choose to eliminate, okay? After that, after we add those 2 equations, then usually we just solve that one equation for that one variable. Once we have that, we just go back and plug that into one of the 2 equations. And then we have both values. I know this doesn't make sense right now, right? Because we haven't seen any examples. Unless you most recently taken a 980 class, which maybe that would make a little bit more sense. And then finally, step 6, which gets neglected quite often. But don't. Okay, because on an exam, the checking part is worth a lot in terms of, I guess, morality. Okay, because if you find that you didn't check it and then you got it wrong, then you can be mad at you. And then check all the time, every time after that. Okay, so make the mistake once and then never make the mistake again of checking your solutions. By the way, eventually we're going to be doing stuff where you got to check solutions anyways. So get used to it now when it's going to help you. It should always help you, really. So here is this system, and it says we must use elimination, which means that you must use elimination on the exam if it says to use elimination. Even though there are other methods which you may enjoy even more. But that's okay. This one's going to be really nice with this example. So the first step we're going to see it because these 2 are already in the same form, standard form for both of these. Right? We've already dealt with some slope-intercept form. We won't see point-slope form. That's nice. But since these are in standard form, we just need to choose the variable we want to eliminate. And the variable I'm going to choose, not that you have to, but I'm going to choose to eliminate the y's first. Why? Because the coefficients of y are already opposites. Okay, one's a positive 2 in the second equation, and then the other one's a negative 2. So now, when I go to add these 2 equations, right, I've got, that's a little big. I've got 3x plus 4x, which would give me 7x's. And I've got negative 2y plus 2y, which, again, that eliminates those. Now, if for some reason you really wanted to put 0y, that's fine, but it still eliminates. Next up, I need to add just the numbers. 5 plus 30, 35. That's pretty nice. So in other words, 7x equals 35. Now, if we would have started this with this equation, we would have liked it. Now that we didn't start with it, we like it even more, okay? Because it's easy to work with, okay? I don't want 7x's, I want 1x, so I'm going to divide both sides by the coefficient of x, giving me the 1x equals 5. In fact, that's not really even the answer. That's only half of the answer, right? Now, we shouldn't forget that the final answer actually is an ordered pair on a graph. So I'm going to replace my x with 5. Now all I need to do is just find the y value. And to do that, I can go back to the original equations, and choose one to solve for the y's. So we got the top one or the bottom one. Let me see if I can get rid of it. Well, I got rid of some of it. So which one do you guys want me to use to solve for the y value? Alright, let's use the bottom one. So I'm just going to rewrite it. So this is it all together, but I know my y value now is 5, or at least I think I do. So I'm going to replace it with 5. Now I have a really nice equation, which I can use to solve for the y value. 4 times 5 is 20. Well, then I just want the two y's by themselves, so I'm going to subtract 20 from both sides. And now to solve for y, I'll just divide both sides by 2, because I just want the one y, right? So y is 5. So my ordered pair, 5, 5, is really my answer. Okay. And it's possible on the homework they may just have you write those in boxes for x and y, or you fill in the boxes for the ordered pair. On the test, I'm okay with either one of these, but whatever you do, just box in your answers, because this is kind of a lot of writing. And if I can't find your answer, I mean, I look for it, right? But it's easier if you box it in, okay? Well, this one isn't quite as convenient because none of the coefficients are opposites of each other. So we can't just eliminate them right away. But it does give us options, okay? Some of us would say, I can eliminate the x's pretty quick because I know lowest common multiple for both. I would personally eliminate the y's here, but I want to do what you guys want me to do. Let's eliminate the y's first. So right now, we have that positive 1 as a coefficient of y in that top equation. But I don't want it to be positive 1. I want it to be negative 8 so that it will cancel with that positive 8. So what I'm going to do is I would need to multiply it by negative 8. So I'm just going to multiply that entire top equation by negative 8. This is a distribution type property, meaning I need to change all the numbers by a factor of negative 8. So it's like distribution. I'm just going to multiply all these by negative 8. All right, well, that's that top equation. The bottom one will stay the same because it already had a coefficient that's the opposite now of negative 8. Well, let's eliminate the y's then. So, right, these are going to go away. Really, they just become a zero pair. And I'll add my 48x's with my negative 4x's. So now I've got 44x's. We already eliminated the y's, and I've got 448 plus negative 96. Now we'll divide both sides by 44 so that we can get the x by itself. And 352 divided by 44 is 8. That's what I got. So that gives us part of our ordered pair. X is 8. All right, x is 8. Now we got to choose which equation we want to use to solve for y, right? And we'll replace x in that equation with 8 because, well, right now we think it's 8, right? And we'll multiply those out. And then we'll add the 48 to both sides. That's just going to give us the y by itself anyways, which is pretty nice. So I've got y equals negative 8. Okay. Well, we didn't do it on the last one. We did skip step 6, which we do in class because of time purposes. But on the exam, you'll have plenty of time, all right? Let's just check this one. So we already used the top equation to find both, or we used both. essentially. I mean, we could check, right? We could go back and replace the y with -8. And in the calculator, if we plug this in, it will, sure enough, give us -56. So the top one does check off. That's nice. But what about the bottom one? I got -4x. And this right now is just a question mark because we don't know if it's true yet. But we are checking. And -48 times 8, -4 times 8, -32. And then 8 times -8 is -64. So when I combine these, do I get -96? Oh, that's great. That was fast. So the bottom one checks off. And now if this were a test, I would feel extremely comfortable and quite happy about circling or boxing in my answer. So I warn against that using one of these equations, right? You're talking about like this red one that we manipulated already. I would avoid those because you've done some work, and if you made a mistake in that work, then it won't show up. Okay, but if you use the original one, then it would show that the mistake could be between the manipulation of the equation or the, I guess, factoring it, not factoring, but multiplying it by a factor there. So on this one, I don't know. There's not really a lot of convenience in this one. If we just focus on elimination, okay? But if we take a bigger picture outlook on this one, we may find something a little unique about this. For example, this top equation, all three of those terms are multiples of 3. So if I multiply this by just 1/3, I may get something a little bit easier to work with. Now, if you had chosen to eliminate something first, that's okay, so don't feel bad about that. But I'm just looking at a bigger picture. If I can simplify it, it may be easier to work with, okay? So let's see if it is. So 1/3 times my 9x, that's a 3x. 1/3 times -12 is a -4y. 1/3 times 3 is 1. All right, I mean, maybe that helped, maybe it didn't. But I can see this bottom equation as well. If I multiply it by 1/4, that may be a little bit more confusing. So let's say we divide it by 4, right? If we think about it as divide by 4, then I got -12x divided by 4 is a -3x. 16y divided by 4 is a +4y. And -4 divided by 4 is -1. It didn't seem like it was going to be so simplified at first, but it turns out it did. Because now, no matter which one we choose to eliminate, it's going to eliminate both of them. But I still need to add the 1s there, right? Well, those eliminated too. So what I end up with is 0 equals 0, which seems kind of confusing at first, right? But the real question is, does 0 equal 0? Yes, it does. Since it does, 0 does equal 0, it's considered infinite solutions. I'm trying to think what they wanted you guys to write. Oh, I spelled solutions wrong. Infinite solutions. What this means is that the two lines that were drawn are actually the same line, which we could see up here. If we had just taken the opposite of one of the equations, it would have shown us that they're the exact same equation. So when we graph it, right, I don't know if this is what it looks like, but if I graph the red one, it may look like this, and then the purple one would be just right on top of it. It's the same line. So how often do they intersect? Everywhere, infinite solutions. Okay, so not everyone comes up with that because that takes a lot of experience and intuition with this math stuff, which most people hate anyways. Right? We look at 9, 12, and 3, and we may not know that they're divisible by each other. So now what we would want to do is, well, they're already in the same forms, so we got to choose something to eliminate. I am going to choose the x's because finding a common multiple with 9 and 12 is going to be easier for me than it is with 12 and 16. Of course, you can use a calculator, which should make it extremely easy no matter which method or which one you choose to eliminate. but I'm going to choose the x's. So what am I going to choose? The coefficient of x to be 36. But you could, if you wanted to, you could use 108. So this top equation, I'm going to multiply by 4. So 4 times 9. All right, yeah, so let's go to the bottom row and multiply it by 3. Kind of squished here. So I'll distribute that into the parentheses. So right there, just put the x's. We'll do the rest of it. But just put the x's, we can see that they're already opposites of each other. So they will eliminate, which is what we want. Okay.
That's okay if you get the opposites.
Okay. So I eliminated the x's, and that's great, but I also eliminated the y's again. And the 12s also will eliminate. So it looks like this one is 0 equals 0. Infinite solution. Why don't you guys try this one? All right, let's eliminate x first then. So the top one is good, but we got that bottom one with the negative 1x. So we'll just multiply that by a negative 3 so that they'll become opposite coefficients there, right? All right, so this one's going to work out nice. The x's will eliminate just as we planned. But let's look at the y's then. 4y plus negative 24y is negative 20y. And then that's negative 22 plus 102, 80. Well, it's going to work out really nice. Divide both sides by negative 20. And that gives us y is 4. Well, negative 4. That's better. So we can put this into an ordered pair. Y is negative 4. Alright, so we'll use the bottom equation to solve for x then. So let's multiply these two. That's a negative 32. And now we'll add 32 to both sides. And right here, I mean, if you want to look at that as a negative 1, some of you guys would just change the signs on both, which is okay. But if you're looking at dividing negative 1, it's the same thing. X is still 2. 2 negative 4. Sorry, I'll box this in to make it a little more official. Let's do this one. Which one do you guys want to eliminate first? Let's eliminate the y's then. So I'm going to go for a coefficient of 6 and negative 6. So the top one, I'll just multiply it by 2 and get a positive 6. And then this bottom equation, I will multiply by negative 3. And now we'll just add these two equations, right? And that's nice because it will eliminate our y's. Negative 8x plus 15x is 7x. And negative 20 plus 27 is 7. So this is going to turn out very convenient. X is 1. So in my ordered pair, I got x is 1. All right, the bottom equation, negative 5 times now x is 1. All right, so let's multiply the 5 and negative 5 and 1, so that's negative 5. And now we'll add 5 to both sides. So I got 2y equals negative 4. Divide both sides by 2, and y is negative 2. Now, remember what the showing our work stuff, or checking our work, we don't necessarily need to show it on the test. So we could just plug these in, right? So I got negative 4 times my x is 1, plus 3 times my y value is negative 2. I forgot to multiply that. And then I got just like elimination though, the first step is not necessarily always necessary for us to use. Because sometimes it will give us one of the variables and what it equals, even if it's an expression. Then we'll just replace that one into the other equation, solve, because it's a one variable equation now. And then once we solve for that unknown or variable, then we go back and solve for the other one, using one of the two equations. Oh yeah, and don't forget to check your answer, that's good. All right, like this one. So the second equation tells us what x is. X is 10 minus y, right? Some people like it if we show this with a little color, so I'm going to just make that red. Okay. So when I look at the top equation, and yeah, I did give myself some extra space there on purpose, because now I'm going to replace the x, right, the x here, with the expression that x is. So now instead of it being 2x, I've got 2 times y, 10 minus y. And now I just solve this, so I'll distribute my 2, 20 minus 2y. Then I would combine like terms myself here, so negative 2y plus that's a 1y, that's a negative 1y. And now I will subtract the 20 from both sides. And yeah, you could divide by negative 1 again on both sides. In any case, y is just going to be 2. So that gives me my y value of 2. Well, on this next part, we need to solve for x. And the second equation lets us solve for x pretty quickly, right? Because x is 10 minus the y value, but now we see the y is 2. 10 minus 2 is 8. So x should be 8. And again, we could check in that top equation. 2 times 8 is 16, plus 2 is 18. So that checks off. This one looks really weird. There's several ways to do this one as well. The most common though, right? Because we don't want negative 4y equals some stuff. We want just y equals stuff. So what I would do, let me rephrase that. What I see very often is that people will divide all the terms in the second equation by negative 4, which is valid. Okay, you can do that. That will give you a y value, but in the process it will also give you a fraction, which some people hate a lot. Okay, but they're still doable on this one, right? So now that I know what y is, I can go into the other equation, x minus 2y equals 5. And once again, I'm going to replace y with that expression. Now they did this extremely convenient for you guys because 2, as I distribute the 2 into the parentheses here, it is going to eliminate the fractions anyways. So we like that. However, this is what I would expect to see, or I do see on tests very often, okay? Okay. This is what I would see on a test. It's wrong. Okay. But if I'm lucky, then I may see something like this. Okay. So instead of that being minus 5, it's plus 5, which is correct, that part. However, what we were distributing into that parentheses was not a 2. It was a negative 2. So negative 2 times that negative 5 halves is going to make that positive 5. But negative 2 times positive 1 half is going to make that a negative. If you want to see the 1x there, that's fine. I don't want you guys to make the same mistake. Well, let's combine our like terms. That's a 1x minus 1x is a 0x. We'll get back to that, but the rest of it was plus 5 equals 5, right? Well, 0x, we can just get rid of that garbage. So we come back to that question, right? Does 5 equal 5?
Yeah.
Yes, it does. So this one has infinite solutions. All right, the other way is to kind of evaluate. All right, I've got negative 4y equals some stuff. And the negative 2y, right, if I can just make that either a negative 4y or if I can make the negative 4y in the bottom equation a negative 2y, then I can replace that. Which kind of sounds weird, right? Here's what I mean. And this is why people hate this, right? Because you guys are looking at me like I already hate it, okay? Well, what I would do is I would divide all these terms by 2. So that gives me negative 2y equals 5 minus x.
What makes you choose 2?
This negative 2y in purple, let me get this working here. This negative 2y is now substitutable with this negative 2y. Right, you guys hate that already, right? Yeah, that's good. And that's okay. This is really x plus negative 2y, so what I end up with is x plus the negative 2y, which is really 5 minus x. And this equals 5. Well, we've seen this before already, right? The x's are going to cancel out, and 5 does equal 5. We like these problems, the infinite solution ones, because it's half the work. We're done. That's that equation, this one, is from this one right here, but I replaced negative 2y with the 5 minus x. Oh. All right, let's try this again. I'm going to use the same method, though, on that last one. All right, so instead of that being a negative 2y, if I can make it a negative 4y, I'm talking about the top equation, then I can replace that negative 4y with the 10 minus 2x, okay? So how do I make that a negative 4y? I'm just going to multiply this top equation by 2. 10. Oh, dang it, yeah. Multiplication's hard. There we go, 10. Thank you. So now that we have 10, or negative 4y rather, I can replace, right, I can replace this stuff into the negative 4y. Not just y, but negative 4y. Now to do this, okay, because this is going to be 2x, and then I'm replacing my negative 4y with 10 minus 2x, right? But if we just keep it like that, then you guys are going to want to multiply stuff. That's why I put that plus there. Okay, so I've replaced my negative 4y with this 10 minus 2x stuff. And this equals 10. Yeah. So on this one, the x's eliminate, and you've got 10 equals 10. So it's a question mark on that, right? Does 10 equal 10? Yes. So you know you have infinite solutions. All right, so that top equation. So yeah, if we add 4x to both sides, right, then we have what y is, 8 plus 4x. But now, in the other equation, I can replace the y with 8 plus 4x. Be careful on this type of substitution as well, because some of you are going to be tempted to replace the y in the top equation. But that's how we got that y equals 8 plus 4x stuff, okay? And it's just going to give you, you're going to think you got infinite solutions, and you're going to feel good about it. But it's wrong, okay? You got to do it in the other equation because it came from, or originated from that top equation. So now we'll distribute the negative 3. All right, now we got this. Which side do you guys want the x's on? The left or the right? It's not going to matter. The left, okay. So I can't have that negative 24 there with it. It's on the wrong side of the equal sign, so I'm going to add 24 to both sides. And I can't have that minus 12x there, so I'm going to add 12x to both sides as well, which gives me 0x's equals 2. Now if we can just look at this and think about it in context, and hopefully it will help us to understand what the actual answer is. I need you guys to tell me what number I can multiply by 0 that gives me 2. And it is not 2. On the other hand, we may have looked at this as 0 equals 2, right? Then we can put the question mark there. Does 0 equal 2? No. So usually on the homework they want you guys to put DNE, right? Does not exist, no solutions. Meaning these two lines will never intersect, That means if we were to draw these two lines, they would be, we've already looked at the word parallel, so they would have the same slope but different y-intercepts. All right, so we've been using substitution. We've seen elimination as well. This one is just a word problem that you'll see one kind of like this on the homework. Find two numbers, a and b, whose sum, a and b, equals -9. But the difference, a minus b, is -1. They gave us a system. That was nice of them. Eventually, you'll have to write the system, though, which you'll feel good about, okay? But we get to choose which method we want to use. And in this one, I am looking at using elimination. Okay, so let's stack these up so we can see them a little better. So hopefully this helps us see why we are going to be using elimination. We got the positive 1b and the negative 1b. So when we add these together, the b's will eliminate. So I've got 1a plus another 1a, that's 2 a's. This equals -10. And we'll divide both sides by 2. So a is -5. Just be careful. I mean, even on tests, I see people stop at this point, which is great. Like you're halfway there, but it's only worth about half the credit. Okay. So let's go in and solve for b now that we have a. I'm going to use the addition equation just to see. So I've got a plus b equals -9, but I'm replacing a with that -5 stuff. And to solve, I'll add 5 to both sides, which will give me b directly. b is -4. So we would just want to check on that bottom equation. A is -5. -5 minus -4. That's really -5 plus 4, which is -1. That checks off. So I got my two answers. It's not really an ordered pair here. It's just two numbers.